Okay, so the tool I chose to use to promote the 4C's in my classroom is an Ozobot. Ozobots are tiny little robots that can be used in the classroom in a variety of settings and across curricula. There's actually two generations of the bots, the BIT and the EVO. Both the BIT and the EVO can perform many of the same functions, but the EVO has more programming options and lights and sounds, and it can also sense if it's fixing to run into something as well. So it just depends on, if you want to spend how much you want to spend. So their function and features, Ozobots cost between $50 and $90 depending on the generation of bot you purchase. The bits are usually run around $50 and EVOs anywhere from $70 to $90. Classroom sets range from $1,600 to $1,800 and come with starter packs for the projects. They have practice books, templates, markers. Some of them even come with coding stickers that you can put on because the bots recognize different color markers and they can spin round and round. Ozobots are capable of being programmed through block coding using the program Ozobots by the user, and they can follow color-coded marker trails, and they can also be driven by the operator from a phone or a tablet. These features make it usable, for all different age groups, depending on their ability levels too, as well. Ozobots can be programmed from a computer, a tablet, and there's even a mobile app, so you can program from your phone as well. That's pretty cool. So as far as the 4C's, they definitely encourage critical thinking during instruction. That the bots provide students with an opportunity to construct knowledge through activity. And programming them or driving them, they actually get to experience, say, the digestive tract while they're moving through it. Students have 3 levels they can use the Ozobots during instruction. All the levels require some form of critical thinking on the part of the students, whether they're driving it, programming it, or using the markers to have different color codes to tell them where to travel and when to turn. They also provide a scaffolding for students to progress in their problem-solving skills during instruction, which can help with the vocabulary acquisition as well. They can start off with the markers and drawing and talking about where they're going through the digestive tract, and then actually be able to program it using Ozobots and use the vocabulary that they acquired during the initial drawing of the lines and going through the tract the first time. So collaboration. They're very conducive to collaboration, of course, because the students can work in groups and have discussions to complete tasks using their bots. Students can make observations, explore and propose solutions to problems, and then engage in the peer-to-peer discussions, which leads to students forming explanations with their new vocabulary that they've picked up through their critical thinking. Ozobots are also great for collaboration between teachers and different curricula. Students can navigate the respiratory system in science and talk about how pollution affects the respiratory system, and then they can map the progress of pollution, say crossing the ocean or traveling through across the United States. Say if there's an eruption of a volcano or something, they could map that in social studies. Communication. Ozobots lend themselves to collaboration among teachers and function across curricula, so they improve the communication between the teachers when planning activities and lessons. They can facilitate communication between students when they're problem solving to teach their learning objectives. Teachers can also, collaborate, like I said, with the, respiratory system and the pollution. So that's another way as well. So to give you an example of how the bots can be used, let's see, make this a little bigger. All right, so we have, these are my bots. This is Bob, and Bob is actually wearing a little suit. The bots are customizable. The kids, they come with suits that they can draw on, add bunny ears or whatever. And then we have Vader. They do come in 2 different colors. They have little eyes and they talk and chatter, move around, so the kids kind of feel almost like they're interacting with a pet. One of the first things that they can do with the bot, one of the simpler things, is that they can actually drive it. If you can see it on my phone because of the light, but it has a little sphere, and you can actually, the kids can navigate it through here and program different features as well, different lights and blinks and beeps and the pattern they may travel. Sometimes these guys have a mind of their own. Another thing they do, which is pretty cool, you can put them down and they'll follow a line. You can take paper and actually draw a geometric shape, or the kids can program it as well. And the cool thing about it, once you put them on there, especially for little kids, of course I think it's pretty cool too, you put them on, get it to follow. Come on, little dude. Okay, so he gets going. If you notice, the lights change color depending on which color marker he's on. So this can be good for math, for geometry, for calculating perimeter. If you put your hand in front of him, he'll stop, turn around. You could also, of course, when you've got your digestive tract, draw marker lines down through here to navigate the tract. Give your students a target. So we're going to go to the pancreas today. You know, what are the functions of the pancreas when you get there? And the little guy will, of course, drive down and go through to your stomach and right around. So could be many different applications with this. The kids love it and think it's fun. The bots will interact with each other if they run into each other, if you've got several traveling around in the system. So they enjoy that as well. Let's see. And then we have the coding part of it. So we've got Ozobots, and this is where the kids can actually program the bots from, and it has different levels. Level 1, just to make the bot move forward, it comes with really simple, just moving, say, 5 steps, and you just pick your block, drag it out, and place it down. Also, instead of telling it to turn left 15 degrees, it gives the kids the options, you know, if they're younger. And so as you move up through the levels, the teaching it how to move, it may be steps, and you can decrease the speed and change it. Also, you know, by the time you get up to level 5, they can actually be using millimeters to measure. They could calculate area, or, you know, to measure the sides, and actually using degrees and having to put those in. The codes, you can pick one out and drag it. They all interact with each other regardless of which level. The lighting effects get cooler as you go up to stoplights, and, you know, if you want to stop in the stomach and turn red. Anyway, so this is kind of the ins and outs of the Ozobots. They're a lot of fun. I'm hoping to get a class set, and I hope everyone enjoyed the presentation. And these are my scholarly readings and references that I read about technology and robotics within the middle school classroom.